Alright, this is the practice final 2019 for Algebra 2. Of course, the actual final is going to be multiple choice and a little bit shorter. Factor each completely. I know that this is going to be a quadratic because it's to the power of 2. That generally means I'm going to ninja star. First up, greatest common factor. There is no greatest common factor, which means I immediately start my ninja star. I'm always going to use an advanced ninja star, that way I don't have to distinguish between the two. I have n, I have -8 on the bottom, -9 on the top. What times what is -9? Well, 3 and 3, but that's not going to work, so I'm going to try 9 and 1, and obviously this is going to be a -9, and therefore we're going to have n minus 9 times n plus 1. Alright, next we need to factor this guy. Again, greatest common factor is going to be 2. So 2 times the quantity of x squared minus 4x minus 60. And then from there, I'm going to factor this inside with another advanced ninja star. So this is going to be x, this is going to be x, this is going to be -60, this is going to be -4. What times what is 60? So I'm thinking 20 times 3, that's not good. 10 times 6, 10 and 6, yeah, that'll work. So 10 and 6, and if I make this one a -10, then that all works out. So then this factors as, still have that 2 out front, I have x minus 10, and I have the quantity x plus 6 as well. I was planning on doing this by myself, but if you guys want me to, I can go through this as a class if you guys want. I think otherwise I probably won't be able to finish in one sitting. Alright, moving on. Again, same instructions because it doesn't give us any new instructions. Yeah, with a bunch of other information. I'll come talk to you in a sec. Alright, I have to factor the greatest common factor, but there is no greatest common factor, so unfortunately I have to multiply this all together. So I realized already that this was a mistake in giving you too large of numbers. It's not impossible, it's just hard. So 7 times -56. Well, what is 56? 56 is really 7 times 8, and 8 again is 2 times 2 times 2. So if I'm looking at just the factors, my factors are 7, 7, 2, 2, and 2. So I'm really multiplying these all together, so that's what I'm going to do for the top number. This number, there's an all call. This top number is going to be k and k. I'm also going to have 41 down here. So what multiplies to all of this and adds to 41? And if let's just, I don't know, take a guess here. I'm going to take this group of 2's. I could choose any pair that I want. I could do these 2 and that 7 as a pair. I'm going to randomly choose these, and that's going to be 8. 8 and 49. Actually, that works out really well. So 8 and 49. This needs to be a negative because this, of course, was a negative up here. I forgot that. That's a negative times a positive should be a negative on the top. And there's my answer, but I messed up because I should have put a 7k and a 7k, which means I need to reduce that fraction. That fraction over here will be reduced to a k over 7. So my final factor is k plus 7 times the quantity of 7k minus 8. Again, I will be making these smaller numbers on the actual final. I apologize for that. Okay, this one I need a greatest common factor first. Looks like our greatest common factor is 4. Yeah, 4. I'm going to guess 4. So 4 times the quantity of 5a squared minus 24a plus 27, I believe. Oh man, those are some big numbers again. So 25 would be 100, so I need to do 2 more than that. Yeah, that makes sense. All right. So from here, again, another advanced ninja star. So for this advanced ninja star, what are the factors of 27? 27 is really 3 things. It's 3 times 3 times 3. So I have on the top up here, I have 3, 3, and 5, or another 3 also. 3, 3, 3, 5, because I'm multiplying these with this thing. And then from there, I know I'm dealing with a and a. The bottom is going to be -24. All right, what things multiply? Well, if I do 27 and 5, I think I get here. So I really didn't need to do this. I know that 27 times 5 does indeed equal -24. So 27 and 5 will make this a negative. And oh, that doesn't work because 27 and 5 I would get to 22. Let's try again. Let's try maybe 15 right here and 9 right here. So 15 and 9 seems like it'll work. They both need to be negative. Okay, that works a lot better. So I have still this 4 out front, a minus, oh my gosh, I keep making this mistake. It needs to be a 5 here, it needs to be a 5 here. This reduces to a over negative 3. This doesn't reduce, so I have over here a.
Attention students.
And the other factor is 5a minus 9. 5a minus 9. And I should make the note that all of these answers are on the final page, so if I came here to number 4, there's a lot of pages here, aren't there? To number 4, we can't check our work. There's our answer. Cool. Coming back up here to our actual work, we are now on number 5. So this one can be still solved with an advanced ninja star. Is there a greatest common factor? There is not. So advanced ninja star. This one is kind of interesting because this one can be rewritten as 16a squared plus 0a minus 9. So there's a missing middle term that I'm putting here by saying 0. And from there, I know that I'm going to have a 16a, 16a, and up here it's going to be multiply these two together. Oh boy, what is that going to be? Fun times. 16 times 9. That's going to be 54, so carry the 5, and that's going to be 144. So multiplying the top together, I get negative 144. On the bottom, I get 0, which is interesting, which means that this number and this number have to be the same number but negative. One is negative, one is positive in order to get 0. That's the only way you can get 0. So what times what is 144? And the answer is 12 and 12. So 12 and 12. And can we reduce these? We can indeed reduce them. They both get reduced and they look like this. I'm going to divide the top and bottom by 4. 16 divided by 4 is 4. 12 divided by 4 is 3. 4a over negative 3. And my final answer is 4a minus 3 times 4a plus 3. I will make the note here, as long as I can have better handwriting, that this is not the way that I actually taught how to do this, and it's because I didn't realize this was so easy. Whenever I said, oh, if you have a difference of squares, you have to know that that's a square term, that's a square term, that's a square term, and there's a minus sign. If all those rules are met, then et cetera, you need to take the square root of that term, square root of that term. That's how we did it the old way, but the easiest way is whenever you have a quadratic, whenever you have a power of 2, try to do a ninja star. The ninja star might not work, and then you have to go to plan B. I'm not testing you on plan B, so it's only going to be a ninja star. Let's look at number 6. Again, there is no greatest common factor between 9 and 12. It looks like it might be 3, but then there's a 4 there. Okay, so again, an advanced ninja star. Advanced ninja star says 9x here, 9x here, multiply 4 times 9, which is 36, negative 12 goes on the bottom. What times what is 36? Well, 6 and 6, and that can get to 12. So if I go 6 and 6, make them both negative, they both add to negative 12, they both multiply to a positive 36. Let's go ahead and reduce those. That's going to be a 3x over a negative 2 and a 3x over negative 2. They're the same number, which means I can write my answer in 2 different ways. I can say 3x minus 2 times 3x minus 2, or equivalently, I can say that that is 3x minus 2 quantity squared. Let's go on to number 7. Find or evaluate each function at the given value. That means plug in 4. This 4 gets plugged in to each of those n's, into this n, into this n, into that n, and I guess if you're being formal, this as well. So my new function looks like this. F of 4. I'm evaluating the function at 4. I'm plugging in for 4, and it's going to be 4 to the power of 3 minus 5 times 4 quantity squared plus 6 times 4 minus 15. The difficult thing with this problem is that we need to keep parentheses. I should put parentheses here as well because I imagine on the actual final I'm going to be giving you a negative number. A negative number to an even power is even. So you need to be very careful with your parentheses if there is a negative number. If you always do parentheses, you will never make a mistake. So from here, 4 to the power of 3 is 6. That's not a 64. 64. And then 4 squared is 16. 16 times 5, what is that? 16 times 5, that's 30, 80. All right, so that's going to be minus 80 plus 24 minus 15. Next up after that, we can combine some things here. I'm going to combine this 64 and this 24 to make an 88. 88 minus 80 is an 8, so I'm now left with 8 minus 15. And then from there, 8 minus 15 is a negative 7. So that means f of 4 is -7, and that is my final answer. On to number 8. I need to divide. So this one is easiest to do with synthetic division. I will always make sure that synthetic division is an option. I will show you, I'm not going to show you the full long way because I'm too tired to do the long way, but the long way would be doing this. P minus 1. Oh, we didn't have to do this one. Never mind. Yeah, you're right. So number 8 wasn't on there because number 8 was from before January, but you can solve it with synthetic division. I really want to show how to do it. I'll show the setup of it. 3, -10, 15, -15. Draw the bar. This gets pulled straight down, 3, and then you multiply by 1 and I get 3, and then I add to -10, I get -7, then I multiply to 1 and I get -7, then I add straight down, I get 8, when I multiply by 1 I get 8, and then I add and I get -7, so the answer here is, this is the remainder, so it would be 3x squared minus 7x plus 8 with remainder of -7, or -7 divided by p minus 1. Okay, we're not going to go through that because it's not on the actual final, so don't worry about number 8. Let's do number 9. Thank you, Fiona. X squared. Okay, so these types of functions, or these types of questions, is it going towards positive infinity or negative infinity? You need to think of the dance, and it's hard to explain the dance without me actually getting in front of the camera, but you need to be thinking about this, or you need to be thinking about this. This function is if I have an even. This function is odd, and that is the positive version. If they're negative, they get flipped over, so that's a positive even. That's the positive and positive odd. And if it's a negative, negative even, a negative even is down here with a negative sign, and this one switches so that my left hand is up instead of my right hand. That's a negative odd. So first of all, ignore everything else except for the first number, the first term. Is that first term, does it have an even or an odd power? It's clearly an even number. That means I'm between these two graphs on the left. And then I ask you, is this coefficient, which is really 1, is that coefficient positive or negative? And the answer is positive, which means it's this graph right here. Both go towards positive infinity. So if both are going towards positive infinity, choose the one that both are going to positive infinity. F of x is going towards positive and positive as x goes to the left, as x goes to the right. So the answer here is D, because these are both positive infinity. Let's talk about number 10 using those same rules. Number 10, this is an odd power, so we're dealing with these types, and is it positive or negative? It is positive. So as I'm going to the right, I should be positive. As I go towards the left, I should be negative. So right means these. These are all the right ones because they are going to positive infinity. So as I'm going to the right, I should be going towards positive infinity. So going to the right, negative infinity. Nope. Going to the right, negative infinity. Nope. Going to the right, positive infinity. Maybe. It's between C and D now. Now I have to check what's happening as I go towards negative infinity. As I go towards negative infinity and negative infinity, I should be going towards negative infinity. Notice that the only one that matches up is D. D is the correct answer. Moving on to number 11. State the number of complex zeros and the possible real zeros for each function. So this is the, remainder theorem. I can't remember the name of the theorem, but the main thing that you need to know is this power is the number of zeros that you will have. You will always have 3 zeros. You will always have, well, I should say at most 3 zeros, at most 5. No, is it exactly? Anyway, there are 3 zeros, there are 5 zeros, and the other thing that you need to know is that if you have complex zeros, specifically imaginary zeros, those always come in pairs. They can't come 1 or 3 or 7. They don't come in odds. They come in evens. So I have 3 zeros because this is a number 3. So there are 3 zeros. That does not answer the question because it's asking what type of zeros do you have. Well, let's make a table. Real versus imaginary. So here's a possibility. All 3 of them are real. I have 3 zeros. If 3 are imaginary, if 3 are real, then none are imaginary. So that is one possibility. Could I have 2? Well, no, that would mean 1 is imaginary, and I can't have 1 and they come in pairs. So let's try 1. That one works. Those are the only possible values. I can't have 0 reals because that would mean there's 3 imaginaries. That is not a pair. Those are all the possible values. Same thing over here. I have 5 zeros. 5 zeros. And from there, I need to make a table of real versus imaginary. All right, well, I could have all 5 of them be real, which would mean none are imaginary. I could have 3 of them be real, 2 of them imaginary, or I could have 1 of them real and wait, what's going on here? And 4 of them imaginary. Those are the only 3 possibilities, and that's it. So just make sure that imaginary is going up by an even amount and starting at 0. Make sure that you have 5 zeros there. That's all there is to it. Simplify each expression. All right, so fractions. What do we know about fractions? In order to add or subtract them, you have to have like denominators. The bottom needs to be the same. If it's not the same, you need to make them the same. These both have the same denominator. They have like denominators, which means I can just subtract it. And be careful with subtraction. This subtraction really gets distributed to each of these terms here, which means I'm really saying this for the numerator. The numerator has m plus 3, and I'm going to subtract an m, add a 5 because a negative times a negative is a positive. That is the numerator. The denominator is m squared minus 7m plus 12. I know that this might factor to, oh, I don't think it does factor. 3 and, oh yeah, minus 3, minus 4. It doesn't matter. Leave it well, actually we do have to check it. It could be m minus 3, m minus 4, so let's come back here. I'm just doing the advanced ninja star in my head. It's m minus 3 times m minus 4. If it does factor, do factor it. It might simplify it a little bit more. My next step here is actually doing this. What is m minus m? That's nothing. 3 plus 5 is 8. My final answer is 8 over m minus 3 times m plus, or m minus 4. Number 14, they do not have like denominators. These are not the same bottoms, which means I need to make them the same bottoms. I do that by saying n plus 6 right here. Wait, that's wrong. N minus 1 right here, because that will work. N minus 1. So I'm multiplying by 1, and I'll get an n minus 1 additionally to n plus 6. This one needs an additional n plus 6 times n plus 6. All right, if I do that, I'm going to leave the denominator as n plus 6 times n minus 1. Both of these have like denominators, so what's left over when I distribute? I'm going to distribute this 5 into the 6 and the n. So 5 times n is 5n. 5 times 6 is 30. Next, I'm going to, and I'll keep my color coded up here, that was distributed in here, and then the green was distributed over here. 3n times n is 3n squared. And then after that, 3n times negative 1 is minus 3n. If I simplify that all into one number, I notice that it's going to be 3n squared plus 2n, because I'm combining the 5n and the negative 3n, and that's going to be plus 30. All that is going to be divided by n plus 6 times n minus 1. But this top might be able to be factored, so let's check it. Can it be factored? If it can be factored, it's going to be factored with an advanced ninja star. 30 times 3 is 90. Put the 2 on the bottom. N and n. Can this be factored? I'm thinking of factors of 90, 9, and 10 is close. I'm thinking of all the factors 3, 3, 2, and 5 of 90, because 9 and 10. I could do 6 and 15. That doesn't get close. I could do 15 and 6. It doesn't look like there are any possibilities here. I'm pretty sure that top cannot be factored, so that's going to be the final answer. And let's check our work, because I'm not 100% sure about that. Number 14. Yeah, you can't factor it anymore. You have to leave the top as it was. All right, we're on to number 15 then. Number 15, simplify each of these, or simplify each and state excluded values. Excluded values are the bad values that are in the denominator. So to do this, I'm going to factor the greatest common factor out. On the top, that's going to be 27n times the quantity of n minus 1. On the bottom, I'm going to factor out a 45n times n plus 2. Notice that these n's do cancel out, and that's as much as I can do. So let's start stating state the excluded values. These cannot be 0. N cannot be 0. N plus 2 cannot be 0. So I'm going to label these excluded values. If you want to simplify this and just say bad values, it's fine. But the excluded values are the following. Excluded values are n is equal to 0 or n plus 2 is equal to 0, which means n is equal to negative 2. Those are the excluded values. N equals 0, n equals negative 2. All right, so we're back. And to do excluded values, yeah, those are done. Now we need to actually simplify this. And really what you have here is you have this 45 and this n. There's like really three things on the top and the bottom, which is the reason I did n equals 0. I'm really setting this n to 0. But I have three things. Can I cross out any of those? N and minus 1 and plus 2. Those aren't the same, but I can cross out this n, and that's all I can do, which means my final answer here is 27 divided by 45. Extend this line a little bit, and n minus 1 on the top, n plus 2 on the bottom. That is as far as I can simplify. There's not much to do. All right, for number 16, we need to multiply. You're going to multiply straight through. Let's go ahead and factor this thing. K minus 1 stays as k minus 1 on the bottom. I'm going to rewrite this. So if I rewrite this, this is going to be negative k squared minus 6k plus 7. And the first thing that I see immediately is that this first leading coefficient is negative. I want to make that positive. So I'm going to turn this thing into, let's do a little arrow here, this thing is going to turn into negative 1 being factored out times k squared minus 6k, or sorry, plus 6k minus 7. I have to switch each of those. The reason I have to factor a negative 1, I can't have a leading coefficient of negative 1. It will break the ninja star. So now that I have that, let's go ahead and do the ninja star. It's going to be k and k. I'm going to have negative 7. Sorry, negative 7 goes on top. Negative 7 and 6. What times what? 7. 7 and 1. I need to make sure that 7 is positive, 1 is negative. So on the bottom here, I'm going to have k plus 7, in parentheses, k minus 1. Alright, and then over here on the top, again, I need to factor that guy, so that's going to be k 1770, and then the answer here is 10 and 7, so k plus 10, k plus 7, and on the bottom I can't do anything, so 10k. I'll leave that as blue. Blue is my default color, so 10k. Alright, so what factors out? Let's start crossing things off. That goes away, that goes away. K minus 1. We also have a k plus 7, k plus 7, k plus 7, and that's it. These look like they're the same, 10 and k, 10 and k. This is being added, this is being multiplied, so it's not the same. After I multiply all the tops, that's gone, that's gone. The only thing left on the top is a k plus 10. The only thing left on the bottom is a 10k, and that is the final answer. I can't go any simpler than that. Number 17 is very similar, where instead of the normal procedure, I have to keep it, change it, flip it. So I'm going to keep it, change it, flip it while factoring. Hopefully you can stick with that. So I'm going to factor out a 3. So it's going to be 3 times b minus 1, then 9. This is going to be changed to a multiplication sign, which means I'm going to flip this. It's going to be b plus 10 on the top, and on the bottom I need to factor this thing. So when I factor that, it's going to be another advanced ninja star. I'm going to have a b, a 9, and a negative 10. That's going to be 10 and 1. Make it a negative 1. And that's going to be b plus 10, which is nice because that cancels out, and a b minus 1. All right, let's start canceling. What do we have here? b plus 10, you're gone. b minus 1, you're gone. 3 and 9, that actually cross cancels down to, that goes to a 1, that goes to a 3. And we're done with 1/3. The answer here is 1/3. And I ran out of time. I would like to go on to number 18, but that's going to be in another video.